Welcome back to Corporate Finance. Last time we talked about interest rates. In particular, we talked about how interest rates are quoted versus how interest rates are used to discount cash flows. We also talked about how to deal with cash flow streams when the cash flows arrived more than once a year or less frequently than once a year, and when the compounding frequency wasn't annual. This time I want to talk about how interest rates or discount rates can vary over time and how that relationship is captured via a term structure of interest rates and a yield curve. Let's get started. Hi everybody, welcome back to Corporate Finance and our second lecture on interest rates. So last time we introduced the topic by talking about interest rate quotes versus discount rates, and we talked about an APR, annual percentage rate, which was a means of quoting interest rates that financial institutions often use. And that's often distinct from what we care about for discounting cash flows, which is an EAR, effective annual rate, or a periodic discount rate. And we talked about how to move between these concepts or these constructs. And then we showed how to apply them to non-annual cash flows and in situations where we have non-annual compounding, say monthly, semi-annual, whatever you might have. Today I want to talk about the term structure of interest rates and the yield curve. And this lecture is a little bit different in that it's not geared towards solving problems per se, at least not directly, because that's going to take us into fixed income valuation, which is beyond the scope of this course. Rather, what it's going to do is it's going to be important to understand what these concepts are, because they're going to be used for corporate decision making later on. So let's get started. All right. Thus far, we've assumed discount rates are constant through time. They just don't change. And what do I mean by that? Well, if I look at my present value formula, right, I take my cash flows and I discount them by 1 plus the discount rate. But notice that's the same discount rate. It's the same number for every cash flow, regardless of when the cash flow arrives. Now, in reality, it seems as if interest rates vary with the term of the investment. Let me give you some examples. Here's a screenshot of home mortgage refinancing rates that I took not too long ago. And you can see that as the term of the mortgage refinancing varies, so too does the rate, or APR, and consequently so does the EAR, the discount rate. Likewise, when I looked at fixed-term CD rates, where remember CDs are just certificates of deposits, their rates tend to vary with the term of the investment as well, and there's a lot of numbers here, so let me focus your attention here. Here we have the term of the investment, right? And here we have the APR and the EAR. Right? And you can see that as the term increases or changes, so too do the interest rate. Now, what's the point here? Well, as the term of the investment changes, quite often, but not always, quite often, the interest rate will change. And the term structure is nothing more than the relation between the investment term and the interest rate. The yield curve is just a graph of that relation. So let me show you a Treasury yield curve from July 24th, 2014. On the horizontal axis, we have the maturity of the Treasury security. So here's a 1-month T-bill, right? Here's a 30-year T-bond. Here's a 5-year T-note. Okay? So these are just different Treasury securities that vary by maturity across the horizontal axis. And on the y-axis is the yield, which for the time being, and in this context, you can think of loosely as the discount rate, R. And the point is that as the maturity of the security varies, so too does the discount rate, right? In other words, when the government borrows for 30 years, it's getting or paying an interest rate just above 3%, whereas when it's borrowing over a short horizon, say 30 days, it's paying basically zero. Now, let me come back to this notion of a yield and what a yield is.
A yield, Y, is the one discount rate that when applied to the promised cash flows of the security recovered the price of the security. And that is a mouthful. So let me actually show you a little formula that you're familiar with to hopefully clarify this. See, I take the price of the security on the last slide, the price of the T-bill, the price of the T-bond, and I lay out all of the promised cash flows to the security. I discount them back and I ask, what is the discount rate such that when I discount these cash flows, I get the price? That is the yield, or yield to maturity. So to build the yield curve, that's just a matter of simply computing the yield for securities of different maturities. And so without getting into the institutional details and the semi-annual compounding and quoting conventions associated with treasuries, let me just talk conceptually. So if I want the 1 year the 1 year yield, I would just take this, say, cash flow at year 1, divide by 1 plus y1, set it equal to the current price, and solve for y. Okay. If I want the second yield, I would take the second security with maybe annual cash flows of CF1 and CF2, and I would solve for the one discount rate, y2, let's call it, such that when I discount these cash flows, CF1 and CF2, I get the price P2. And we do that for all different maturities. And the y's that come out, y1, y2, y3, all the way down to yt, that represents the yield curve. Those are the points on the yield curve. But that's the same as computing the discount rate for securities with different maturities, hence the link between discount rates and yields. Now, there is a difference between discount rates and yields having to do with promised versus expected cash flows, but that's a little bit outside the scope of the course, so let's leave that aside for now. And in the context of treasuries, yields and expected returns are relatively close. Now, one thing I want to emphasize is that yield curves, in other words, interest rates, they move around a lot, or at least they can. And so to illustrate that fact, I've plotted 3 yield curves here. The purple one is from 2012, the blue one is from 2000, and the red one is from 1981. And you can see that the rate at which the government was borrowing has varied dramatically over time. Right? Today, for short-term loans, they're not paying any interest. The interest rate's basically zero. But back in 1981, the interest rate was around 15%. Okay? The other thing I want to point out is that the relationship between the short end of the yield curve, short-term interest rate, and the long end of the yield curve, long-term interest rates, that can vary over time as well. Here, at least in 2012, we see that the curve is upward sloping so that interest rates, short-term loans to the government, are less costly than long-term loans. Whereas back in 1981, we see that long-term interest rates were actually below shorter-term interest rates, at least over a stretch here. So it was cheaper for the government to borrow at longer rates, or for longer terms at least, at a lower interest rate. Now, this raises the question, well, what does this mean? What does the upward sloping curve in 2012 mean as opposed to the downward sloping curve in 1981? Well, there's a lot of academic debate about that, but one popular opinion is that the slope reflects expectations of future interest rates. So when the yield curve is upward sloping as it is in 2012, this suggests that future interest rates are likely to be higher. Whereas back in 1981, this downward sloping portion, also actually in 2000 it looks slightly downward sloping as well, the downward sloping curve suggests that future interest rates are going to be lower. Treasury yield curves, what they're doing is they're graphing the relationship between interest rates on risk-free loans and loan maturity. So they have a very special meaning. When we talk about the risk-free rate, we're really talking about the interest rate or the yield on treasuries. But we can plot yield curves for a host of different securities, and that's what I've done on this next slide, is I've got 3 different yield curves. The blue curve is the yield curve for high-quality corporate debt. Right? So you can see that for, what do I mean by high quality? That's investment grade, think triple B or higher. Okay? So when high quality or highly credit rated firms were borrowing for, say, 29 years, it's costing them about 5% per annum, at least as of July 2014. Whereas when they're borrowing short term, say 2 years, it's a little over 1%. The green curve is the yield curve for municipal bonds, AAA rated municipal bonds as of July 2014. And then the red curve is the Treasury curve. And what's sort of interesting to note is that the yields or the cost of borrowing was higher, appears to be higher for the federal government over at least certain periods than it was for municipalities, which is strange if you think that our federal government is a much safer bet than a municipality, even a AAA rated municipality. But what's going on there is mostly a tax differential as well as some liquidity issues. Okay? All right. So what's the lesson here? Well, look, yields vary by maturity and risk. So to illustrate that point, I'm going to look at the yields on corporate bonds. And you can see as the ratings, credit rating improves from BBB to AAA, which is the best rating, okay, the yield goes down. And I know drawing the up arrow isn't helping, but the numbers are getting smaller. And they're getting smaller within each maturity bucket. Right? 1 to 2, 2 to 5, 5 to 10, 10 plus. Right? And that's a result of decreasing or credit risk. Right? These are safer bonds. These are safe. These are less safe, but still relatively safe. The other thing to notice is that within a credit rating, say AAA, the yields or the interest rates are different. Now, in this case, they're increasing, but as we showed a few slides ago, right, they don't always have to be increasing with maturity. They could be decreasing. Okay? The point is that they're different across the maturity spectrum. Now, all of these interest rates that we've discussed thus far are referred to as spot rates. And what are spot rates? They're the interest rate for a loan that's made today. Now, typically, there's a different spot rate for loans of different maturities and different risks. That's what we showed right here. These are spot rates. They vary by credit risk, and they vary by maturity. Okay. Now, what's one of the big punchlines or takeaways from all of this, aside from just general knowledge and information and understanding interest rates? Well, this present value formula that we've been working with is in many ways just an approximation, because we know interest rates vary over time. So it's really an approximation for this. Now, it's not such a bad approximation when the yield curve is flat. So when we have a yield curve, here's maturity, here's yield. When the yield curve is flat, R1, R2, R3 are the same. So these two things would be equal. The problem, let's see if I can erase some stuff here. The problem is when the yield curve is, say, upward sloping severely or even downward sloping. Now there's going to be a pretty big difference from using some sort of average discount rate R as a proxy for all of the different spot rates. Okay. So let's wrap up here. What did we talk about today? We talked about the term structure of interest rates, which captures the relation between interest rates and the investment term. Right? Loans or savings of different maturities, different terms, will often have different interest rates, and that relation is captured by the term structure. The yield curve simply graphs the term structure, right? It plots on the horizontal axis the maturity, on the vertical axis the yield or the interest rate, and that shows us the relationship between investment term and interest rate. We also learned that interest rates will vary by the risk of the investment, though we discussed that earlier on back in our first lecture. And we talked about spot rates, which are the interest rates for a loan that's made today. So, what's up next? We turn to a new topic, discounted cash flow. I look forward to seeing you then. Thanks a lot.